All right, good morning. I'm planning to do the LeetCode biweekly contest 76 this morning. So this is last Saturday's contest. All right, here we go. Open these guys up. And here we go. Find closest number to 0. Alrighty. Just take the absolute value of whatever it is. Let's see. Best equals 25 plus 1. Return best. Oops. Take equals 25 plus 1. That works, right? So what do we take? For x in A, if abs x is less than best, best is less than, yeah, best exceeds that, then best equals that. Right, so just do this. Best equals that. And then take equal x. 1 and -1. 1 is larger. Return the number with the largest value. There's a tie. Okay, so take can be an array. Best is equal to abs x. Take dot append x. Maximum we can take. Looks good. Number of ways to buy pens and pencils. Number of distinct ways you can buy the number of pens and pencils. Price of a pen is 10, price of a pencil is 5, buy 0 pens. Oh, okay, so you can use rule of product. Let's see, 10 to the 6, number of distinct ways. You buy 0 pens, you can buy 0, 1, 2, 3, or 4 pencils. Just performing the simulation should work based on depth of research and backtracking. I'm going to try it. Let's do this. 618. How many minutes for the game plan? DFS plus BT, I think will work. We're supposed to skip or take pen. Skip or take pencil. Right, so all possibilities. That's the answer. Okay, so let's see. Let's just do this A and B, which are total. Def go. Let's see, start with T. Total is T. Turn go. T is less than A and T is less than B. We don't have enough to pay for either. It's 0, that's base case. Otherwise, we'll do take or skip pen, pencil. First, let's see, if T exceeds A, then we can take the pencil or pen, or whatever it is, whatever A cost. Count equals 0, return the count to the end. Count plus equals go. There's one way to do this, right? One way to go this way with taking A. Count it as a way, yeah. Okay, so T minus A. Likewise, if B is less than or equal to T, then we can take one of those. T minus B. And then we also want to consider the case where we skip A in favor of B. Take A, right? Otherwise, out A, but with B. How do I simulate without A, but with B? I want to alternatively take A's and B's. With A or without A? With A. Okay, yeah, so let's do this. With A or without A, with A or without B. How am I going to write this? Hold on. Take A first and then as many B's as we can. Take B first and then A as we can. It's the opposite. So how do I express this in code? Let's do a Boolean flag maybe. Take first or take second first. First equals true. With first and first is not true. First is false. We'll try to take B first, always. And then, no. Take A's and then take B's, right? Take A or don't take A. Take A or don't take A. Take B or don't take B. Without. Yeah, this is interesting. I think I'm quite confused. So you can spend part of all your money, right? So you want to do piecemeal at a time. Then we can iterate as well, right? So while T A is less than or equal to t. We can take it a in piecemeal chunks. Count plus equals 1 plus go t minus a with. Then how do we do the b's in between? So I want like a for loop and then backtrack, right? Excuse me. How many a's are we going to take? T equals 0. We have to take one of something though, right? We have to take one at least. Or no, we don't want to take one sometimes. Sometimes you want to take 0. 0 a's and then sometimes a b. A's we can take, now b's we can take. I want to take something, right? So let's do this. Maybe we can do a and b are the initial values of this guy. Or pen and pencil. A equals pen, b equals pencil. Or just a and b, right? A, b. Okay, so if we stick these as parameters and go, let's see how many a's we have, let's see how many b's we have. 0, 0. So we can multiply the count of a times a, that's the cost. Count of b times b, that's that cost. So if a times a plus b times b exceeds our total t, then we're done, right? T is less than that, then that is not a way. When did this thing bottom out? When it's exceeded. So maybe recursion is not the best way to do this then. Distinct ways, right? Maybe I should just go through and perform the simulation. Take one of these in the outer loop and then take one of these in the inner loop. Okay, hold on. Yeah, so 6, 18, 6. Okay, so about 10 minutes for game plan. I don't think this is simple enough, right? KISS equals keep it super simple. Let's just do 2 loops for like a quadratic. Quadratic? Is it quadratic? Quadratic? Yeah. Quadratic runtime. That is big O of n squared. Okay, let's do this. Okay. So let's see. So if brute force TLEs, then we need to, then right, maybe we need to use of product calculation more efficient. File. Let's see if we have. Let's see if we have X and Y, the amount of pens and pencils we have. So while A times X is less than or equal to T, it's a big T since it's not going to change. Total for this iteration equals T minus A times X. While B times Y is less than or equal to T, total with that amount of XAs taken, how many BYs can we take? Before we take a BY, we can increment, well, so once we get to the end of the BYs, that it's one way. T minus equals B times Y. Count plus equals 1. Nine and then 1. Uh-oh. T, oh. Not true. If A times X exceeds T, then break. Wait a sec. T. This is the maximum amount of A's we can get, T divided by A, right? T divided by A. For X in range. Does blind nothing count as a way? By something, right? 10 and 5. Oh, I'm making this way harder than it needs to be, actually. So the outer loop will be 0 through how many I can buy. Inner loop is just dividing that total by that. Okay. Okay, I was way overthinking this one originally. So we can just have a single loop and then increment count by what we can take within what would be an inner loop, which we don't need to iterate on. Now we take the floor of dividing the remaining total by what's left from the outer loop. I think that works. Okay, so for x in range, how many you can take? Floor will be total evenly divided by a. T equals t minus times x amount of a's that we'll take. And then inside of that, we can take how many b's. So count plus equals how many b's we can take remaining of that, t divided by b. I think that works. 6, nope, that's not working. 4 plus 1, choose plus 1. Plus 1 because you can take 0 plus 1 if not x. 0 pins, you can take 0. So 0 and 0 does count. Right, 0 and 0 counts. So yeah, it is plus 1, right? Plus 1. 1 plus. They're both 0. Why does this count? Print 5 and then 3. So 5, 1, 2, 3, 4, 5, 3. And then if you buy only these, you cannot buy any pencils. So it should have been 2 pens. We have nothing left. Oh, so if it's 0, that counts as 1. Buy 2 pens, you cannot buy any pencils. Each iteration should count as 1, regardless then. Each iteration should count as 1, regardless if you can take any. Each iteration counts as 1. So how is this working? So f equals 0, we take 0 pins. T equals 20. T equals 20 minus 0 times 10 times 0, which is 0. It's 20. Count plus equals 1 plus 20 divided by 5 equals 1 plus 4 equals 5, which is right. I get 5 pencils with 0 pens. Otherwise, we take x equals 1 pen, right? We take 1 pen. T equals 20, t equals 20, right? Minus 10 equals 10. Count plus equals 1 plus 10 divided by 5 equals 1 plus 2 equals 3. And then when x equals 2, we take 2 pens. This should be 1, right? So t equals 20. T equals 20 minus 20 equals 0. And then count should equal 1 plus, right? 1 plus t divided by b, which is 0. Oh, wait. To b, t is 0. 0, right? That's 1. Five, 8, and then what's that last? Oh, okay. So this is non-inclusive, right? So plus 1. Okay, that works, I think. Right? Okay. And then the other one is 1. 9 and 1. That looks right. Okay. Yay. Okay, so totally gotta remember to KISS. It's super simple. Okay, how much time do we have left? 1 hour, 3 minutes. Okay. Design an ATM machine. I'm gonna go grab some coffee real quick. I'll be right back. Music going. All right, there's ATM machine, it stores 5s, 5 denominations. Okay. empty. User can use the machine to deposit or withdraw any amount of money. When it's drawing the money, the machine prioritizes using larger banknotes. Okay. 300, you'd use the 200. Yeah, I mean, if it can, it'll take the biggest ones. Okay, that's what it's saying. Machine is not allowed to use $200 banknotes instead of the 500 because there's one of these. 600. I can't use all three of these. You have to use the biggest first. Okay. Should just be able to keep track of how many notes we have, right? 0 20s, 0 50s, 1 100, 2 200s, 1 500. Okay. So, okay, 6:45 a.m. dash whatever it was. Probably started at 6:43 or something. I don't know. 6:45. 2 minutes for game plan. The game plan is this, right? Just greedily consume largest bills first. Banknote count, though, there's a billion of these things. Amount 5,000 calls. At least one call made to these. There's 5,000 calls. It should be fine. It seems pretty simple, right? Seems pretty simple at first glance. Let's see what happens. Implementation. Let's try to 6:45 or 46 minutes for that. Whatever. Let's see. Nice. Dot map. Okay, so $20 bills, there's 0. $50 bills, there's 0. $100 bills, there's 0. $200, there's 0. $500, there's 0. Just crunch this up. 20, 50, 100, 200, 500. Okay, count, deposit, that'd be an array. Draw X. Okay, so first index maps to 20. How do we want to store this? Maybe my array can be I don't know, self.bucket, maybe mapping of buckets. No, let's not make it too complex. Self.a. Let's make an array, right? It's fine. 0 times 5. For I in range 5. Self.a plus equals I plus equals a sub I. Okay, so deposit's pretty simple. Withdrawal will be maybe more complicated. Take equals 0 times 5 for I in range. I want to reverse this, right? First. Does that work? I don't know. I don't think it does, no. I want to go 5 down to 0 non-inclusive, right? I don't know. 5 down to 0 non-inclusive. have equals 0, and this is what we take. If we have is equal to x, then we can take what we have, right? So it's a list return we take, okay. Return take after we update self. Have, how about what we have? If sum of what we have is equal to x, then return what we have after we subtract what we take. Take equals the minimum of x minus half, and take x minus half is what we need. All right, so this is need. Take is then self dot a sub I evenly divided by need divided by that denomination of a sub I. This is the count and the value. Count self dot value. Self dot count self dot value. Count value. 20, 50, 100, 200, and 500. All right. Okay, self dot count sub I plus equals a sub I. So take the value of the I denomination, need evenly divisible by the value of that. So how many we will take? This quantity that we will take. X. Am I going to reduce x? Yes, if not x, to reduced x. X minus equals take times self dot val sub I. That's how many we can take of that denomination. Have need is x in this case. Need equals x. Need if not need. Okay, so need is x, have is the denomination, or the individual fields of denominations, 20, 50, 100, 200, 500. Take the biggest one we can, which is 500. Take as many as we can of 500. Need divided by the value, which is 500. So how many we can take of that? So have, right? Have sub I plus equals what we take. Need, I'll move this down here, it's fine, whatever. It's not plus equals, but just equals. Half of I equals what we take. For I in range 5, self.count sub I minus equals half sub I. Otherwise, we'll return -1. Right, we don't have what we need. Okay, that looks good. Oop, out of range. I is out of range. Oh, it's 4. 0, 1, 2, 3, 4. 5 non-inclusive. 0 to 4 inclusive. Okay, let's look at what this is here. Compare that output to this guy. Looks good. Uh-oh, no, that does not look good. -1 is not correct here. Okay, so 6:56 a.m. About 10 minutes. Wrong answer. For some reason, we are returning -1 instead of, or no, returning this instead of -1. Instead of -1. Okay, so let's see what's going on. Okay, so when we deposit, we have 0.20s, 0.50s, 1/100, 2 200s, and 1 500. Okay, so that's my deposit. And then I want to withdraw. Draw 600. Should take a 500. Take 100. That's what we're saying. 500, 200, 100. Okay, so that's right. Checks out. Okay, and then we're going to deposit these guys. Actually, after we withdraw that, we should have 0 and 0. I suppose we can print these out as we go too, right? Okay, and in this case, we will print sub.count for it. So after that, okay, so that's what that is. And then we're going to deposit this guy. So now we should have 50, 3 of those and 1 of those. Okay, now we're going to withdraw 600 again. Withdraw 600, so it should take 500 and a 100. Or don't have a 100. Oh, dang. Okay, in this case, we can't take it. Okay, so we need to try the next one. Okay, so that's why. Aha. Bug identified. When we cannot take 600 by greedily consuming the largest first, then we must backtrack, right? Okie dokie, so let's do backtracking. Okay, so So we'll recursively do the backtracking. Need equals X, and then the item that we're at, I equals 4. If I is less than 0, then return. Okay, so what will the recursive function return then? There's no need, then it's okay. If not need, this is where we can take and return. Otherwise, do DFS with BT. Keep track of the path too. Half equals 0 times 5. Take and return what we have. Return nothing, right? We cannot take this denomination. Denomination. Empty array, maybe. Return what we have. Okay, so take as much of the ith as we can for chain range I down to 0 non-inclusive. Take equals what we need divided by self.value of the jth denomination. Half sub j plus equals what we take. Need minus equals take times self.value sub j. Backtrack. Oh, dang, that's not good. Okay. Thank you. Can't say it. Sure, it's okay. First. Oh, so we took something, let's return that on. Perfect. Oh, dang, I'm supposed to go back to 200. Okay. Nope. Before and after what? Delta counts. Okay, that was right. Put down the wrong problem again. Good reminder that communication is key. Okay. Just the roundabout way of doing it, but okay, it's about 30 minutes in. Communication, 20 minutes. Right. And that's okay. People actually sort of okay, so the figure above shows the graph and chosen node sequence 0, 1, 2, 3. The score of the node sequence is 5298. 5298. Why is it 52? Oh, these are the scores. 52984. It's shown that no other node sequence has a score of more than 24. The node sequence is 3120, 1023, also valid, score of 24. Sequence 0324 is not valid since no edge connects nodes 0 and 3. There are no valid node sequences of length 4, so return -1. There's an edge connecting every pair of adjacent nodes. Adjacent nodes in the sequence, so those are not adjacent. 0 and 3 are not adjacent. Some of the scores of the nodes in the sequence. N is 50,000 edges. 50,000. Seems like a minimum spanning tree that you can add on to any existing nodes. So maybe Prim's algorithm to greedily consume the next adjacent one, or union find Kruskal's algorithm. I suppose it would make sense to do union find. Does that work? How would you union find these funds? Why is 4 not included? An edge connecting every pair of adjacent nodes in the sequence. No node appears more than once in the sequence. So it's a walk then, in that case. Maximum path. Yes, the maximum path. It's undirected to. Why is 4 not added here though? Oh, because you walk this way instead of walking that way. Walk this way instead of walking that way. So how do you efficiently walk the graph? Do some pre-processing via linear graph algorithm, and then do some dynamic programming to backtrack and find the optimal solution. I think a greedy algorithm is probably what we're aiming for, right? It makes sense for the source to be score the largest value, I would think. The figure above shows the graph. There's no valid node sequence of length 4. 0, 1, 2, 3, 6. N equals score dot length. 1, 2, 3, 4, 5, 6. So N is 6 here. return the maximum score of a valid node sequence of length 4. So this is the most important thing, probably right here, which is easily overlooked. Length 4, a path of length 4. Do DFS with BT for each start and end? I wonder if DFS with BT will work. All possible start nodes. Let's try it. Right? Let's implement it and see what happens. Adjacency list is this guy, and then for UV and list of edges, use not in adjacent. Let's just do this. Default tick set. Insert that in the adjacency list. Bidirectional. Okay, so there's our adjacency list for each edge. And let's do this fast. This is one. Turn fast. Let's try it. Def go. Right U. Go and return the best. Non-local best. Or should we turn best as recursive stack on ones? No. We have to go for each of those. Or in range. In. Okay, so in. And equals length of A. Max best estimate candidate. Okay. Go will return the maximum from that starting position. How many hops we have as well, right? Hop equals 0. If hop equals 4, then return 0. Equals 0, return best. -1. Within 4 hops. Best to be 0. If best exceeds 0, else -1. Best candidate. Score V and adjacent to U. Score V can equals score of V, which is A sub V, plus best is A sub U, A sub B plus go V plus 1 at the next hop. Next hop for V, and then keep track of what's been seen too. Seen equals set view has been seen, then return infinity. Return infinity. 0. Shoot, I don't want to go back to that thing. Or actually, let's do this. Let's not even consider it as a possibility. If V not in scene. Scene dot add V. Scene dot remove V. Backtracking for that, right? Add it, stick it on there. Come back out. It's different candidate. Candidate. Best. Take that fourth hop and then return 0. TFS plus BT. So I'm gonna go best here. I'm gonna go best. Have step. Maximum best what we have. Return. Go sub I. Best. That's this. Have plus equals A sub V. Have minus equals A sub V. Go V. What we have one more step. It's been seen. E is not seen. We've taken 4 steps, and that's the best of what we have. Okay, that was right. I said DFS was BT. Uh-oh, set has no attribute. Insert, add and remove. Hop is not defined. Yeah, I changed hop to step. Where's hop? Hop, 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 hop. I don't see hop. Oh, hop. There's step. Step. 17. No, it should be 24. 17. Not sure how I got to 17. Path. Starting at U. This is what we've seen. This is what we have. This is what's best. Zero, 1, 3, and 2, starting at 0. Have plus best. Have plus equals. Doesn't look right. Have plus equals. No. Have starts off at ace of I. $33. Oh, scene has to beat that as well. Instead of ace of I. Have and path. Length of the path. That's path. V is not in the path. Add it to the path. Backtracking. Path. Okay. Int object is not iterable. $31 is not correct. Zero, 1, 2, 5. 0, 1, 2. There's no 5. What? Path. What? 0, 1, 2, 5. 0, 1, 2, 3, 4. And there's 5 edges, but then there's only 0, 1, 2, 0, 2, 0 through 4. Something's not right. Not quite right. How much time do we have left? 8 minutes. See what's going on here. How is 5 getting on the path? What the heck? Print the adjacency list. Zero is adjacent to 1 and 2. 1 is adjacent to 2, 3, and 4. Well, how's 1 adjacent to 4? What the hell is this? Oh, okay, yeah, that's right. Okay. 1 is adjacent to 0, 2, and 3. Okay, that's right. Okay. 2 is adjacent to 0, 1, 3. 0, 1, 3, and 4. Okay. 3 is adjacent to 1 and 2. That's right. 4 is adjacent to 2. Okay. Adjacency list is correct. Starting at each ith value, we have a sub I, and we've seen, we've seen the set of ith nodes. B is adjacent to U, so this is the problem, right? Okay, that looks right. And try the other one. It should be -1. Looks good. Okay, let's get rid of this. Get rid of this and submit that. Cross your fingers. It's taking a long time. Might TLE. Eee. Okay, TLE'd. Let's see what we got here. 40 out of 63. And so we got to come up with a better way of doing this. Okay, so I started on this one about 7:10, I think. 7:10 a.m., 7:39, 29 minutes for TLE. Oops, hold on. 5 minutes left. Let's see, where was my missed? Oh, I mean, whatever, I guess it doesn't matter. We'll upsolve this later, right? We got 5 minutes left, we'll cut it short. All right, cool. Okay, cool. I'll plan to upsolve this later. Yeah, thanks for watching. Cheers. Get you next time.